Here is our second problem, and see the Pn comes in terms of n. Like all the problems of mathematical inductions comes in this form. And the solutions of these problems you can find in every book, but I will do it I will give you a little bit easier way so that you can handle this type of problems so easily. Okay, so first you have to find out Pn. Oh, okay, you already have the Pn here. Pn is 3 to the power 2k minus 8k minus 1 is divisible by 64. For the solutions, the base steps. So what is our base step? For n equals to 1, you have to prove. We know, okay, we now put n equals to 1. If we put n equals to 1, this looks like 2 to minus 8 into 1 minus 1. And this is equal to 9 minus 9 is equals to 0. And 0 is always divisible by 64. Okay, so from this statement, we can say that P1 is true. Alright, now we make an hypothesis like before from the mathematical induction. So what is our hypothesis? Hypothesis is we assume that Pk is true. That is our assumption. Pk is true. And k, what is k? K belongs to natural numbers, any k. We write these things. What does this mean? Pk is true. This means 64 divides this. That is 64 divides 3 to the power 2k minus 8k minus 1. This is the same with 3 to the power 2k minus 8k minus 1 is divisible by 64. Okay. Next, we can write this in this way. 3 to the power 2k minus 8k minus 1 is divisible by 64. That is 60 multiple of 64. M is, for some m belongs to integers. Well, we have to calculate now the final step, calculation of Pk plus 1. So calculation. What is Pk plus 1 looks like? You have to put k plus 1. You have to replace k with k plus 1. Now calculate these things. 3 to the power 2k plus 1 minus 8 into k plus 1 minus 1. Okay. First, you just on simplification, you have to simplify so that it looks like Pk type. Minus 8 minus 1. Okay. So this is the things on simplification. We are getting this. Okay, just a minute. Well, just we rewrite this again. 2 to the power 2k, 3 to the power 2k dot 9 minus 8k minus 9. Okay. What do you have to do now? You have these things. This is a k plus 1 steps. You have to use k steps. What are you gonna do? You have these things and these things. In such a way, you have to break it down so that you can apply these things. Pk, sorry, this is our Pk. You have to apply these things. How are we gonna do? If you multiply these things and these things, you get 72, right? 72. And you can break down this 72 in this way. If you want to break this 9, this will be more like 9 is equals to 72 minus 6 to 3, or 8 is equals to 72 minus 64. So whatever you like, you can put here. I break it this way. 2 to the power 3k into 9 minus 64 is 72 minus 64 k minus 9. this is equivalent to 3 to the power 2k into 9 minus 72k minus 9 plus 64k. This is equals to, look what happens, you can use pk terms. Well, you get this, and 64k. This, look, this is divisible by 64 from the hypothesis, because in the hypothesis you said pk is divisible by 64. This is true. From this is of course divisible by 64. Therefore, we can write these things is divisible by 64. Therefore, pk plus 1 is true. Since pk plus 1 is true, we can say that Pn, that is Pn is true for all n belongs to natural number. That's what we wanted, so we are done. Well, another one approach you can do. You have these things. Okay, so after that you can break these things, you can break these things. If you don't want to break these things, so there is another easiest way. Here in the case steps, you have 3 to the power 2k positions, 3 to the power 2k elements. So took these things, 3 to the power 2k, and write it right, 3 to the power 2k minus 8k minus 1. Okay, now add the things or subtract the things what you have extra added or subtracted. See, these things you have to remove. Plus 72k plus 9, and here you have 8k and minus 9. Okay, you are getting, this is pk divisible by 64, and this term is 64. This is being cancelled out. It is easy. This is from the hypothesis, this is divisible by 64, and this is of course divisible by 64. So we can say is divisible by 64, and which is exactly the thing that pk plus 1 is true. Since pk plus 1 is true from the mathematical induction, therefore we can say by mathematical induction Pn is true for all n belongs to natural number. We are done.